Hey everyone, in this video what we're going to do is we're going to approximate the square root of 28 multiplied by the cube root of 1031. For the first solution, we will approximate each of the roots individually to one decimal point and then multiply the two results together. So how can we approximate the square root of 28? Well, we can get a rough approximation by considering perfect squares on both sides of 28. For example, if we draw a line containing these three numbers, 28, 25 and 36, and take the square roots of each of them, we get 5, 6 and the square root of 28. We can see that the square root of 28 is more or less in the middle of 5 and 5.5. Now we want to approximate the square root of 28 to one decimal point. So based on the fact that the square root of 28 is more or less in the middle of 5 and 5.5, a fair choice would be 5.2 or 5.3, right? Let's go with 5.3. Now we can check that 5.3 is a reasonable approximation to the square root of 28 by squaring it and seeing how close it is to 28. So we have 3 times 3, which is 9, 3 times 5, which is 15. Moving on to 5, we have 5 times 3, which is 15. We write down the 5, we carry over the 1. 5 times 5, which is 25, and we add the 1 from before that we carried over. Now, in the two numbers that we're multiplying together, we have 0.3 and 0.3, so we have two numbers before the decimal points. That tells us that we need to have two numbers before the decimal points in the calculation that we're doing. So we get 1.59 plus 26.50, which gives us 28.09. And 28.09 is very close to 28, so our approximation is reasonable. So we're going to take the square root of 28 to be approximately 5.3. We can now do the exact same thing to approximate the cube root of 1031, but because we have a cube root, we're going to have to consider perfect cubes instead of perfect squares. If we draw the following number line and take the cube roots of each value, we can see that the cube root of 1031 is much closer to 10 than 11, or 10.5 for that matter. So let's take our approximation of the cube root of 1031 to be 10.1. And we can check that this is a reasonable approximation by cubing 10.1 and seeing how close it is to 1031. Doing so, we get 10.1 cubed is equal to 1030.301. Again, this value is pretty close to 1031, so our approximation is reasonable. So we're going to take the cube root of 1031 to be approximately 10.1. And all we need to do now is multiply 10.1 and 5.3 together to get our final answer. 3 times 1 is 3, 3 times 0 is 0, 3 times 1 is 3. Now multiplying everything by 5 we have 0, 5 times 1 which is 5, 5 times 0 which is 0, and 5 times 1 which is 5. So we have 3.03 plus 50.50, which gives us 53.53. And that's the final answer for solution 1. Let's move on to our second solution. Let's consider a function of two variables, f of x, y, with continuous first order partial derivatives, f sub x and f sub y. We can define the total differential of f as df is equal to f sub x dx plus f sub y dy, is the small variation experienced by f when the variables x and y are changed by infinitesimal amounts dx and dy respectively. Now, by infinitesimal amounts, we mean very small amounts. So let's define the following function of two variables. F of xy is equal to x raised to the 1/2 power times y raised to the 1/3 power. Notice that it's easy for us to evaluate our function when x is equal to 25 and y is equal to 1000. Doing so, we get the answer of 50, because the square root of 25 is 5 and the cube root of 1000 is 10, and multiplying 5 and 10 you get 50. We can now use the fact that the point at which we want to compute the value of f of xy is very close to the point 25 1000. For example, the point we are interested in is 28 1031, and we can rewrite this as 25 plus 3 and 1000 plus 31. Now what we're going to do is we're going to figure out what df is. We begin by computing the partial derivative of f with respect to x. Doing so, we have df is equal to y raised to the 1/3 power dx divided by 2x raised to the 1/2 power. And we add the partial derivative of f with respect to y times dy, which is equal to x raised to the 1/2 power dy divided by 3 y raised to the 2/3 power. And what we're going to do is we're going to take x to be equal to 25, dx to be equal to 3, y to be equal to 1000, and dy to be equal to 31. If we plug in these values into our formula, we get that df is approximately 3.52. And we now get that our approximate value of f evaluated at the point 28 1031 is approximately equal to f evaluated at the point 25 1000 plus df. And plugging in the values for our two functions, we get a final answer of 53.52, which is the final answer for our second solution. Now before we finish this video, let's compare our two answers to the value that we get when we plug the square root of 28 times the cube root of 1031 into our calculator. The calculator gives us an answer of 53.45626,002, which is approximately 53.46. So we can see that our solution 2 is slightly more accurate than solution 1, but just by a little bit. Anyway, thank you very much for watching. I hope you found this content useful. If you did, could you please make sure to like and subscribe? I hope you have a great day.